Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. This video was created to help us discuss about the continuation of chapter 5, but this time we have to discuss about new sub-discussion, which is about geometric mean and harmonic mean. Okay, let's start it from the geometric mean. What is meant by geometric mean? Geometric mean is the average obtained by multiplying all data in a sample group, then rooted with the number of data samples. The geometric mean is a type of average usually used for growth rates like population growth or interest rates. While the arithmetic means adding items, the geometric means will multiply the item. Also, you can only get the geometric mean for positive number. So, from this paragraph, you can catch the difference of arithmetic mean and the geometric mean. While the mean, the mean, arithmetic mean is actually the average that we know in the first part of this chapter, that we call as x bar, or we can call it as mean, the common mean. Okay, x bar is sigma x divided by n. Okay, this is actually that meant by arithmetic means. So I want you to know that the common mean or the common average, at least we can name three of them. The first one is arithmetic. This is okay. The second one is geometric. Which is discussed in this slide, and the last one is harmonic mean. Okay, I'm sorry. So yes, okay, we just continue this slide away. Okay, in this slide we will discuss about the geometric mean of ungrouped data first. So the geometric mean is actually has three different formula. The first one is for ungrouped data, the second one is for group data, and the last one is the measuring average of growth. But we just gonna discuss about the two first that I said. There are ungrouped data, so geometric mean for ungrouped data and geometric mean for group data. So this is the first one. There are two ways to calculate geometric average for ungrouped data. Apart from ungrouped data, there is also group data. There are two ways to calculate the measuring average, namely the first one is multiply method. This is a simple method, and the second one is logarithm method. Actually, these two calculation is the same, but just for the uses of the two of them is a bit different. Okay, the first way is the multiply method. You can write it as this. Okay, you can write it as this, which is g equal square root of n from the multiplication of the value x1, the multiplication of all of the x actually. So there is x1 times x2 times x3 and so on until the nth x or the last x. This method will be easy to do if the amount of data is not too much. But if the data is in the tens of or hundred, of course it will not be easy to multiply all the values in the dataset, because the value or the result of the multiplication will be even greater. It will be greater and much greater if the data is more than the simple data set. The use this then okay, then we can use the second method, namely with the help of logarithms. All values in the data are logged first, then do the arithmetic mean formula. This is the formula of second way, or we can say the logarithm method. Okay, this method actually can be written as this: log g is 1 over n times log x1 plus log x2, log x2 plus so on until log x nth. Okay, we suddenly go to the next slide by chance. This is the example of geometric mean for ungrouped data. We ask to determine the geometric mean from 2, 4, 8, 16 and 32. So the solution, we can use the two methods of this. This is the first method. G or geometric mean is equal, or G equals square root of n from the multiplication of value 2, 4, 8 and so on. So we can write it as this until we get this value. G is equal to the n. The n is 1, 2, 3, 4, 5, so the n is 5. Oh, I'm sorry. G, this is square root of 5. Okay, the square root of 5. So we can write the result of this multiplication: 32,768. Okay, so we can calculate it in this way. We'll raise this result or this value with the reciprocal of the root. G, we can write it as well like this: 3, 2, 7, 6, 8. We'll raise with the inverse number of root 5. So this value will be raised as the power of 1 over 5, 1 over 5, and it is 8. You can check it in your calculator with this step. Okay, try to calculate it in your calculator by this step. Okay, uh, and as well as this logarithm method, we can write it as here. Okay, please pay attention to this subtraction. It is not multiplication, so the value won't be great. Okay, that is why if the data is too much or hundreds and more, it won't be easy if you multiply by the first method. You can use the logarithm method to set the value or the result is smaller than the first method. Okay, I will continue to the second one of geometric mean. This slide is discuss about geometric mean of group data. For group data, or we often see it in frequency distribution, the measuring of geometric mean can be calculated using this formula: log G equal to sigma f times log x divided by sigma f, which is the x is the midpoint of class or of interval. So here we must first calculate the midpoint of class for each interval class. Do you guys still remember the steps to calculate the midpoint? I think you still remember. Okay, good. We must add up. Okay, the x is the subtraction and the fraction of the lower and the upper limit. Okay, we have to add up the lower limit with the upper limit, then divided by 2, or we can say that they are multiplied by half. Okay, so this is the step or the way to get the midpoint of class. We have an example here. Determine the geometric mean of the following frequency distribution. This is table 4.5 measurement result of 100 starfruit leaves. Okay, there are two columns of the table. The first column is the measurement and the second one is the frequency. So in order to we can calculate the geometric mean of that table, we have to find the midpoint. So we have to find the midpoint and then the log x, and the last one is f log x, which is add up all so we can get the sigma. Okay. Okay, we have to make it as a new table like this. Add in the right side x log x and f log x. To calculate x, I have said that x for the first class is half from lower limit of this class. Lower limit, this is the lower limit, and this is the upper limit. The lower limit is 50 and the upper is 54. 104 times by half, so 52. And the second class, the midpoint is okay, in short word. Okay, we can write this. Okay, I hope you all can calculate it by yourself. Then the log x, it is just simple. You just need to use your calculator and type the log, then enter the value that you are wanna know the log value. So if it log 52, log 52 is you just type it in your calculator and you gonna get this value, and so on. The last one, it is just multiplying the number that you need, f multiplied by log x. So 6 multiplied by this, 10 multiplied by this, and so on. And don't forget to subtract it so you can get the sigma. Yeah. Then we go to here to the formula to calculate the geometric mean. This is the final step. This and this. Okay, put the value, this value in this formula until you get this value. Log g equal to 1.834. In simple word, log b, I have log b. Let's say that I have log b. Log b is the same as 10 log b, or we can write it as 10 log b, usually write as just log b. So it is same with log g. If we have the log g is 1.834, so the g is 10, so this 10 to the power of 1.134. Okay, so you can try in your calculator and you can get this value as well. Okay, so I think the discussion about this geometric mean is over, and we continue it to the harmonic mean. I'm sorry. The harmonic mean is a type of average that is calculated by dividing the number of values in the data series by the sum of reciprocal of each value in the data series. The harmonic mean is calculated as the number of values n divided by the sum of reciprocal of the values, or we can say that 1 over each value. The formula is look as simple, but not exactly as simple, is it? You're supposed to have a sample. So let's say that you have number 1, 2. Oh, I'm sorry, I'm not supposed to write 1, so you won't get it wrong. 2, 6 and 7. Okay, let's say that we have data series a sample of data series like this. So you have to change it into the reciprocal form, which is will be right as 2, the reciprocal or the inverse is 1 over 2, and the 6 will be 1 over 6, and so the 10 is will be changed as 1 over 10. Okay, this is the harmonic mean. And what is the formula form? Harmonic mean of data can be divided also into two types, the harmonic mean of ungrouped data and for grouped data. The first discussion is about harmonic mean of ungrouped data, which is formulated by RH. This is the harmonic mean, and you can notate it as H only, H, or harmonic equal to N divided by sigma 1 over X. For example, determine the harmonic mean of 3, 2, 4, and 3 again. So you have to make it as the fraction of reciprocal of that data series. In the formula, it's supposed to be like this. It is supposed to be like this. Okay, so if you have the denominator in the fraction form, so we can get started to work on it. Okay, let's work at this multiplication. RH equal to 4 divided by 1 over 3 plus 1 over 2 plus 1 over 4 and 1 over 3. We can subtract the fraction with the denominator that different. Okay, this is the numerator and this is the denominator. Numerator and denominator, which is in bahasa we can call it as pembilang dan penyebut. Okay, so if I say the denominator, I mean the penyebut as well. Okay, to make the same denominator, to equalize the denominator, while the numerator will be adjusted by multiplying number as for the denominator as well. Okay, so for this fraction, we have to make it as the equal denominator. I think it should be 12. Okay, 3 to 12, 2 to 12, 4 to 12, and 3 to 12. It is easier and it is the small value of this number, and we can just make it as this. So the 3 value to be to have a denominator as 12, it have to times by, or it have to multiply by what? 1 over 3 to be something over 12. So I'm sorry, it will be like this. Okay, so the same as the denominator, numerator should be multiplied by the same number of it. Okay, multiply by 4 and multiply by 4, so we can get 4 over 12. Okay, we get 4 over 12 plus 6 over 12 and 3 over 12, and the last one is 4 over 12. RH is 4 4 and 6, 10 and 17. Okay, oh, I'm sorry, 17 and divided by 12. So I will continue it up in this area. Okay, the harmonic mean of 4 divided by 17 over 12 can be write as, or we can calculate it as 4 cross this multiplication 12 over 17, so we can get this number. Okay, okay, please try it by yourself so you can gonna understand it easily. Oh no, oh okay, oh I don't know. Okay, I'll continue to the next slide. The harmonic mean of group data. Harmonic means for group data are formulated by this formula, and for the example we are using the example problem in table 4.5 in the geometric mean discussion, and let's calculate the harmonic mean. So we have to write again the table down here. Of course we have to write just the interval and frequency because we have to add up other the other column. The first column in the right side is for x, and the next one is for f over x. And don't forget to subtract all of the value for the frequency and for the f over x, so we can get the sigma. Don't forget of the formula in this slide, sigma f divided by sigma f over x. So we just put the value to the formula and calculate it. Okay, nah, we actually have the different from arithmetic average than this harmonic average for many uses. And of course the harmonic mean can be used to calculate other cases, not only this speed average, but I think we just have to discuss about this one. Okay, the harmonic average or speed data. Let's go to the example. The average speed should be calculated using the harmonic average. Why is that? Try to consider the following illustration. For example, Alessa drives a car from city A to city B, which is 60 km away at a speed of 60 km per hour. Arriving at city B, Alessa immediately returned to city A at a speed of just 30 km per hour. What is the average speed of a car driven by Alessa from city A to city B and back to city A again? So, if we calculate the average by arithmetic mean, then the average value of the speed of the car driven by Alessa is like this: half times 30 plus 30, 60 plus 30, sorry, and it is 45 km per hour. Okay, don't forget that the arithmetic mean is x bar, which is x bar is sigma x per n. The x is 2 in this case, and of course the n is 2. Why is it 2? The first n, the first x I mean, is 60 and the second x is 30 divided by 2 because the n is 2, so it is 45 km per hour. But actually the average value is biased because it doesn't reflect the actual average. Why is it biased? Because actually the distance traveled by Alessa is 120 km, 1 kilometer away and 1 kilometer return. A to B, okay, plus from B go back to A, so the distance is same. If we add the distance for the commuting, it will be 120 kilometers. So the difference is the time of the travel. Okay, the first one, the speed is the speed is 60 km per hour, and the return travel is half of that, 30 km per hour. So if this travel need 60 over 60 is 1 hour, so this commuting is need 2 hours because the speed is half from this one. Okay, the speed of I'm sorry, thus the speed of Alessa commuting is 120 km with 3 hours of time, so the average should be 40 km per hour. So this actual average is different to the arithmetic average. Therefore, the arithmetic average is not appropriate in estimating the actual average. So, what about the harmonic mean? If we use the harmonic mean, we have to make it like this, and it will be get this result. So, the average value of the harmonic turns out to be same as the actual average of this. It is the actual and this is the harmonic. Therefore, for cases like this, the harmonic average is more appropriate to use than the arithmetic average. So this is the end of the sub-discussion of this chapter. I think you all can resume for the for a whole chapter 5 of central tendency. So please read carefully for this. What is okay? I can say it is the assignment, but you have to you have to write your comments in the column in Google Classroom column, of course, and including your name and presence number. So this is all for me from me today, and thank you. Assalamualaikum warahmatullahi wabarakatuh.